Walk up to it slowly, because that's the only way your eyes can actually process what you're looking at. 8 tires, each one taller than a grown man standing beside it. A cab perched so high off the ground it looks like it belongs on a crane, not a tractor. A hood stretching out in front of you like the nose of something that should be flying, not ploughing. This is the Big Bud 747. Park a modern high-horsepower tractor next to it, one with satellite guidance, a touch-screen cab, and enough. Onboard computing power to rival a small aircraft, and something strange happens. The new machine looks smarter, it looks sharper, it looks like the future, but it doesn't look bigger, it doesn't look more dangerous. It doesn't make your stomach turn the way Big Bud does the first time you stand next to it. Decades of engineering, decades of software, decades of precision agriculture, and somehow nothing built since has managed to feel quite this extreme. So here's the question worth sitting with. Why does a machine built in the 1970s still look like it shouldn't exist? To answer that, we have to go back to the environment that made it feel necessary in the first place. By the middle of the 20th century, American farms weren't just growing. In parts of the country, they were becoming industrial operations measured in the thousands of acres. Out west and across the northern plains, some farms stretched further than a person could walk in a day. Fields weren't small rectangles anymore. They were vast open expanses that swallowed ordinary equipment whole. A conventional tractor, pulling a conventional implement, could only cover so much ground in a day. On farms stretching into the thousands of acres, that limitation added up fast. Farmers needed fewer passes, wider implements, and machines that could keep pulling without stalling out in heavy, compacted soil. This wasn't about vanity. It was about time, fuel, labor, and the brutal economics of scale. Every extra tractor in the field meant another operator, another fuel bill, another machine that could break down at the worst possible moment. Montana became an unlikely epicenter for a solution. A small manufacturer there had already been experimenting with articulated four-wheel drive tractors, machines built by taking components designed for trucks and heavy equipment and reassembling them into something built purely to pull. These tractors weren't dainty, they weren't polished, they were closer to industrial machinery wearing a tractor's clothing. And by the mid-1970s, one particular request would push that philosophy further than anyone had gone before. The request came from California. Elmer and Melvin Rossi ran a cotton operation in the Bakersfield area, working soil that needed to be broken open deep beneath the surface, a process called deep ripping, where heavy tines are dragged through the ground to loosen compacted layers far below what a standard plow could reach. One option on the table was brute force the old-fashioned way, a fleet of Caterpillar D9 bulldozers, run side by side across the property. It would have worked. It also would have meant multiple machines, multiple operators, and multiple fuel bills just to do one job. So the Rossi brothers went to Northern Manufacturing Company instead, based in Havre, Montana, the same small operation already building oversized articulated tractors for farmers who needed more than the market offered. The machine that came out of that request was developed by the team at Northern Manufacturing under owner Ron Harmon, with engineer Keith Richardson playing a lead role in the design. The goal wasn't to build the largest tractor in the world for the sake of a record. The goal was narrower and more practical. Build one machine that could do the work of that whole bulldozer fleet, pull the widest possible ripping implements in a single pass, and do it reliably, season after season. Construction began in 1977, and the tractor was completed in early 1978. They called it the 16V747, a name borrowed from the Boeing 747, the biggest passenger jet in the sky at the time. It would later become known simply as Big Bud. It wasn't built to impress anyone. It was built to solve one very specific, very physical problem, but solving that problem required engineering decisions that pushed the entire concept of a farm tractor somewhere it had never gone before. At the center of Big Bud sits a 16-cylinder Detroit diesel engine, roughly 24 liters in displacement, originally rated at 760 horsepower. Over the following decades, that number crept upward through successive modifications, into the high 800s, then the high 900s, before the Williams brothers, later owners of the tractor, installed higher flow injectors in 2011 and pushed output to around 1100 horsepower. That kind of power wasn't about bragging rights. Deep ripping through compacted soil creates enormous resistance. Every foot of ground fights back. An engine this large existed to keep pulling steadily under that resistance, without bogging down, without stalling, without needing a second machine standing by. The power alone wasn't enough, it had to reach the ground. Big Bud rides on 8 custom-built tires, each standing roughly 8 feet tall, specially manufactured because nothing off the shelf could handle the load or the flotation this machine required. Spread across 8 contact points instead of 4, that weight, reported at somewhere around 100,000 pounds depending on configuration and fuel load, gets distributed across a wider footprint. Less pressure per square inch means less compaction and less risk of simply sinking into the same soil it was trying to break open. The frame itself pivots at the center, an articulated design borrowed from heavy earth-moving equipment, rather than traditional tractor engineering. Instead of steering with the front wheels alone, the entire front half of the machine turns relative to the back half. In a machine this size, that's not a stylistic choice. It's the only way to make something this long and heavy capable of turning at all in a working field. Even the transmission and axle components leaned on components pulled from heavy trucking and off-highway equipment, rather than anything built specifically for agriculture. Big Bud wasn't assembled from a tractor parts catalog. It was assembled from whatever heavy industry already knew how to build strong enough. Every one of these decisions traces back to the same demand: pull wide, pull deep, and keep pulling. Numbers on a page don't do it justice. You have to see a person standing next to the front tire to understand what this machine actually is. A man standing beside Big Bud barely reaches the top of a single tire. The cab sits high enough above the ground that climbing into it feels less like boarding a tractor and more like climbing a piece of industrial scaffolding. Photographed beside a conventional tractor of its era, Big Bud doesn't look like a bigger version of the same machine. It looks like a different category of object entirely. Out in the field, pulling a ripping implement stretched across dozens of feet, the effect only intensifies. This wasn't a machine dragging a small attachment behind it. This was a machine towing something closer to a piece of construction equipment, tearing into ground that would have stopped smaller tractors cold. This is the point in the story where a farm implement stops looking like agricultural equipment and starts looking like something built for a mining operation or a military supply line. And that's exactly the sensation Big Bud still produces today, decades after its engine first turned over. At what point does big stop being a reasonable engineering answer and start becoming something closer to an extreme experiment in how far a concept can be pushed? Big Bud sits almost precisely on that line. If a machine this powerful could solve a real problem, why didn't every large farm eventually get one? The honest answer isn't dramatic. It's economic and it's mechanical. The 747 itself was effectively a one-off, a single machine built for a single customer's exact problem. Northern Manufacturing, and the Big Bud name that followed it, would go on to build far more tractors over the following decades. But nothing else was built to quite this extreme, because a machine at this scale means custom tires, custom frame components, and fabrication that doesn't spread its cost across thousands of buyers the way mass production does. That custom nature came back to bite it in the most literal way possible. The 8 enormous tires had been made by a single specialty manufacturer. When that manufacturer stopped producing them, replacements became almost impossible to find. A tractor with a fleet-replacing engine and a bulldozer-replacing frame was ultimately slowed down by something as ordinary as running out of tires. Meanwhile, the rest of the industry was solving the same underlying problem: pull more, cover more ground, work more efficiently, through a different path. Rather than building one machine to an extreme, manufacturers leaned on smarter implements, more efficient traction systems, improved tire and track technology, and eventually, precision guidance that let a moderately sized tractor cover ground with far less waste and far less operator fatigue. Agriculture didn't decide that bigger was wrong. It found a more repeatable way to get similar results, one that didn't depend on a single supplier for a single irreplaceable part. The Rossi brothers used Big Bud for 11 years, deep-ripping cotton fields exactly the way it was designed to. From there, it moved to a Florida farming operation for more of the same work, and by the late 1990s, it had come home to Montana, bought by brothers Robert and Randy Williams, who put it back to work pulling wide, cultivating implements across their own fields. It kept working for years. What finally slowed it down wasn't its engine, its frame, or its transmission. It was the tires. When the original tire manufacturer stopped producing them, Big Bud's 8 custom giants became almost impossible to replace, and by around 2009, regular fieldwork came to a stop. For years afterward, Big Bud lived a quieter life, appearing at shows, museums, and farm equipment exhibitions, drawing crowds who had never operated a tractor in their lives, but instinctively understood they were looking at something extraordinary. Then, around 2020, it received a full set of new tires and returned to the Williams family's Montana operation, proof that its retirement was a pause, not necessarily an ending. Among collectors and machinery enthusiasts, Big Bud occupies a specific kind of legendary status. It's frequently referenced as one of the largest farm tractors ever constructed, though even that title requires context, since largest can mean different things depending on whether you're measuring length, weight, horsepower, or footprint. What isn't up for debate is its cultural weight. Even now, when a manufacturer unveils a new high-horsepower tractor, comparisons to Big Bud tend to follow within days. Not because the new machine is necessarily bigger, usually it isn't, but because Big Bud became the reference point for what extreme looks like in agricultural machinery. It became a benchmark, not through marketing, but through sheer physical presence. Modern tractors have moved in a different direction. Guidance systems that steer within inches. Engine management run by onboard computers and sensors instead of mechanical feel alone. Cabs that feel more like control rooms than driver's seats. In almost every measurable way, today's machines are more advanced than Big Bud ever was. And yet none of them make you stop in your tracks the way Big Bud still does. That's because Big Bud was never really an answer to how agriculture would evolve. It was an answer to one farm's specific problem, built by people who weren't interested in restraint. When a bigger implement was needed, the response wasn't caution. It was a bigger engine, bigger tires, and a bigger frame to hold it all together. Modern engineering chose intelligence. Big Bud chose scale. Both paths solved real problems. Only one of them still stops people in their tracks nearly 50 years later. Big Bud isn't just an old tractor that survived. It's proof of what happens when someone looks at a field too big for ordinary machines and decides the only honest answer is to stop being ordinary. Some machines get remembered because they were efficient. Big Bud is remembered because it was fearless.